Hey everybody. So we're getting into chapter 8 here that deals with exponents. All right. And today we're going to start out by looking at some of the basic rules for exponents. So go ahead and get this title here, and we're going to kind of break down this first rule. All right. So we have a squared times a cubed, or a to the power of 2 times a to the power of 3. You might kind of instinctively or already know what's going on here, but here's technically what's happening. When we have a squared, if you guys remember, that is a times a, right? And it's saying we're multiplying that by a cubed, which is a times a times a. Okay, well, if we were to multiply, 5a's together, we would get a to the power of 5. Okay, and that's exactly what we would get here. Here's the thing: we don't need to do this step where we break these down. Okay, we can just remember the rule, and the rule is when you multiply two numbers that have the same, or numbers or variables with the same base, you add their exponents. So a squared times a cubed would give me a to the power of 5. Okay, so there is rule number one. Technically, this is called the product of powers. Okay, so go ahead and get this rule here, and then we'll try it out, and then we'll get to the next rule. Okay, so again, this is when we have the same base, and that means this base is either the same variable or it's the same number. Okay, and if that's the case, we just add exponents, and we have our new, I guess, condensed number. Okay, so let's go ahead and try this out. Okay, so take a second, copy these two examples. All right, so on number one, I have negative 2 to the power of 3 times negative 2 to the power of 5. Okay, first things first, because this is the same base number, negative 2, I can use my rule to just add my exponents. Okay, so negative 2 cubed times negative 2 to the power of 5 is going to give me negative 2 to the power of 3 plus 5, 8. Okay, here's one thing I want to point out. Notice that there's parentheses around this negative 2. That actually matters. Okay, if there wasn't parentheses around this negative 2, say this problem instead looked like this, okay, what we would actually be implying is that this would be a negative positive 2 to the power of 8. Okay, and if you were to multiply this number, you would take positive 2 to the power of 8, whatever that happened to be, and then you would slap this negative sign in front of it. Okay, but that's not the case. We're taking a negative 2 to the power of 8, okay, which would be negative 2 times negative 2, 8 times. Okay, so just a little technicality, but that's why there's parentheses there, just by the way. Okay, let's take a look at number 2. Okay, so we have this three numbers being added together. They all have a base of 7. Okay, so we can use our rule. Here's the thing. We have a 7 to the power of 6 times a 7 times a 7 to the power of 8. What is the exponent to this 7? Okay, what is this taken to the power of? Okay, well, you probably know this, but if a number is ever just by itself with no exponent, technically it's being taken to the power of 1. Okay, so there's an invisible 1 there, so we would want to, include that when we add our numbers together. Okay, so 6 plus 1 would give me a 7. 7 plus 8 would give me 15. So this would be 7 to the power of 15. Okay, and if you want to put little boxes around these, that always kind of looks nice. Okay, so now that you have seen those, go ahead and try a couple of these on your own, and then we'll get to the next rule. Try it out. Okay, so these just so happen to be bases that are variables. That's okay. That doesn't change anything. As long as they're the same base, we can use our rule. These both have a base of x, so we can go ahead and add these exponents. So x to the power of 4 times x to the power of 3 gives me x to the power of 7. All right, moving down to number 2 here. This is kind of the same idea. We need to remember that this y right here is technically to the power of 1. So when we multiply all of these y's together, we're adding together 1 plus 3 plus 2, and it looks like we're going to be getting y to the power of 6. Okay, so yeah, really simple rule. Let's keep moving along. Okay, the next rule is called the power of a power rule, and it's what happens when we have numbers that are outside of the parentheses, basically an exponent of an exponent. Okay, so go ahead, copy this rule, and I'll show you what's going on. All right, so when we have problems like this where there's a power on the outside of the parentheses, okay, technically a power of a power, here's what we do. We will multiply the exponents. Okay, so a to the power of 2 to the power of 3, and technically, I guess let me show you what's going on here. A to the power of 2 to the power of 3, that would be a squared times a squared times a squared, right? Okay, and we know that when we multiply these together, that would give us a 6. Okay, so yeah, you can see that's why the multiplication rule works. So a squared to the power of 3 is a to the power of 6. Okay, and in your directions, let's just kind of point out that's what we're going to do, multiply. Okay, so power of a power, multiply. Let's try it out. Okay, so again, go ahead, get these 4 examples here, and we'll try them out. Okay, so taking a look at number 1, we have 2 to the power of 5 to the power of 3, power of a power. We know we're going to multiply those together. So we're going to get 2 to the power of 5 times 3, 2 to the power of 15. Okay, so easy enough. Moving on to number 2. Just kind of, this looks a little different, but technically this is still a power of a power. Don't let the brackets and stuff throw you off. By the way, the reason why brackets are being used here is since they already have parentheses around this -6, they then use brackets to make it look, a little bit easier to understand. All right. So yeah, the same idea here. We're just going to be multiplying these together. So we're going to get a -6, which still needs to be in the parentheses. 2 times 5 gives me a power of 10. Okay, moving on to number 3. Same idea as number 1 here. The only difference is the base is a variable, but that's fine. That doesn't change anything. We're still multiplying our powers, and we're going to get x to the power of 2 times 4, 8. Okay, and then last thing over here, again, don't let this stuff throw you off. This y plus 2 is just the base. All right, what really matters is this, the power of a power. All right, so we're going to do 6 times 2, and we're going to get a power of 12 here. So I'm going to write it down here. So this is going to be written as y plus 2 to the power of 12. Okay, so yeah, those are your answers here. Let's put boxes around all of them. All right, so yeah, power of power, multiply, pretty easy stuff. I'm going to have you guys try this out. Okay, so go ahead, try these problems here, numbers 1, 2, and 3, and go ahead and see if you remember the rules. Careful, it might not just be power of power. Okay, so these practice problems, if you guys take a look on number 1 here, this is not power of a power. This is going back to our very first rule, which is a little reminder of the name of it, is product of powers. Okay, by the way, you don't need to memorize the names of these rules, but it's a good thing to just kind of keep in mind. Okay, so product of powers, this is just us when we have 2 of same bases being multiplied, we're going to add the exponents. So this is going to give me m to the power of 8 plus 9, 17. Okay, be careful. If you accidentally multiply these together, that's not what we do on this. We add together when we have the same bases. Okay, on number 2, we have power of a power. This is when we multiply. So this is going to give me a 4 to the power of 2 times 2, 4. Okay, and then on number 3, same idea, power of a power, all right? This is going to give me a -2 to the power of 4 times 5, 20. Okay, so -2, don't forget, that needs to be in parentheses. That negative is part of the thing that's being taken to the power of 20. Okay, just real quick, I want to illustrate, again, I want to point out why these brackets are here. Say instead of brackets, they use more parentheses. This is what this problem would look like. Parentheses, parentheses, -2, close parentheses, 4, parentheses, 5. This is kind of confusing looking. Okay, there's a lot of parentheses here. That's why when there's parentheses within parentheses, they change the outer ones to brackets. It looks cleaner. It makes more sense. That's the only difference. I just want to point that out. Okay, so let's take a look at our third rule here. This one is called the power of a product. Go ahead and get this thing. Okay, so here is the rule for a power of a product. I guess the one thing to notice is notice how there's multiple terms. I guess, no, not terms. There's multiple numbers inside of the parentheses. You know, technically these are being multiplied together in here. This is an a times b taken to the power of 3. Okay, here's what happens. This power of 3 needs to be applied to both of, or I guess rather all of the numbers inside of the parentheses, all of the things that are being multiplied together. Okay, so what happens is this a gets a power of 3, and this b gets a power of 3. Okay, so again, everything that's inside of the parentheses that's being multiplied together gets the power applied to it. That's the power of a product rule. Okay, so let's use it. All right, so go ahead, take a second, copy these 4 examples. We'll do these together. Okay, so taking a look at number 1 here, 24 times 13 to the power of 8. Here's the big thing we got to realize. Since there are 2 things in here being multiplied together, both of them are going to get a power of 8 applied to them. I like to kind of show this. You can kind of think of it as distribution, though technically it's not. But yeah, we're going to distribute the 8 to both of these. So this 24 is going to get a power of 8 times this 13 is also going to get a power of 8. Okay, and for these problems, that's all we need. We could go farther. We could get a calculator out. And we could actually multiply all this stuff together. But for now, this is all I really care about is just using the rule. Okay, let's take a look at number 2. Here's the big thing to realize. On number 2, we have 3 things being multiplied together inside of these parentheses. All 3 of these things, and I use the word things just as general, but all 3 of these are getting a power of 2 applied to it if you want to show yourself that by doing the little lines. Okay, so this is going to be a 9 getting, let me change it to black. Okay, 9 is going to be getting a power of 2 times x is going to be getting the power of 2 times y is going to be getting the power of 2. Okay, so there it is. All right, and just one thing to point out, normally these multiplication dots, they would not be shown. This would normally look like this: 9 squared, x squared, y squared. Okay, here's another thing I want to point out, and this is normally a rule that we'll follow in this class. If we have something to the power of 2 or 3, normally I'm going to have you guys actually do that math. You know, we know that 9 squared, 9 times 9 is 81. We could go one more step here and write this as 81 x squared y squared. Okay, normally that's what we're going to be doing in this class, but for these problems, applying the rule is all I care about. Okay, but normally if it has a power of 2 or a power of 3, I'm going to ask you to do that math. If it's anything higher than that, you can just leave it as 9 to the power of 4 or 9 to the power of 5 or whatever it would happen to be. Okay, take a look at 3 and 4. These problems look a lot alike. The only difference is this one has our minus sign inside parentheses. This one has it on the outside. Okay, we're actually going to do the math on these just to make a point and show you why the parentheses matter. Okay, so here's the big thing. On this one, 2 things inside the parentheses that are being multiplied. So this negative 4 is going to get a power of 2. Okay, and that needs to stay in parentheses. Okay, and this z is also going to be getting a power of 2. Okay, let's go one more step. Let's actually do this math here. Okay, if we were to do negative 4 to the power of 2, that's negative 4 times negative 4. That's a positive 16, right? So this would give me a positive 16 and then z squared. Okay, on the next problem, this negative is not in the parentheses. Okay, what that means is that negative just kind of sits here outside. Okay, and what happens is this 4 is getting a power of 2, and this z is also getting a power of 2. Okay, here's the big thing. Since there's not parentheses around the negative is not part of what is being squared. The only thing that's being squared here is this 4. Okay, and we know that 4 squared is 16. Okay, but that negative just sits there in front. So that is still there. 4 squared is 16. Z, we still have z squared. Okay, and that is our answer. Okay, notice the difference. On this one, we got a 16z squared. On this one, we got a negative 16z squared. Okay, and again, the reason why is because when that negative is in the parentheses, it's part of the number that is being squared. This was a negative 4 squared. On this one, this was just a 4 squared with a negative sitting in front of it. All right, a weird technicality, but something I want you to be able to make some sense out of. Okay, so I'm gonna have you guys go ahead and try out these two problems on your own, and then I think we'll look at one more together. Okay, so on number one here, first thing to notice, two things being multiplied, we got this power of 2, it needs to be applied to both of them. All right, so on this problem, we get a 42 to the power of 2 times 12 to the power of 2. Okay, and if I wanted you to, I would then ask you to then square these numbers, 42 squared, and then get 12 squared, and then multiply those together. But for now, this is okay. We're just practicing doing the rule. Okay, over here on number 2, let's go ahead and we have a -3 in parentheses. So that -3 is being taken to the power of 2, and then n is also being taken to the power of 2. Again, if you want to show that like this, you can. Okay, on this problem, let's go one more step because we can do this in our head. Okay, we know that -3 squared, -3 times -3 is a +9, and then that n squared just tags along. Okay, so that's our best looking answer for this one. Okay, so yeah, there it is. Here's the last thing I want to look at. What happens when we get a problem that has a lot of those rules crammed together? Okay, I'm going to give you a little kind of glimpse on what our following lesson is going to look like. Okay, but let's try this example here and then we'll be done. Okay, so there's quite a bit going on here. Here's, I guess, the first thing to always worry about when you get problems like this. Worry about the parentheses first. Okay, here's what I see. We have this power of 2 on the outside of this parentheses. There's two things inside of here. There's a 2 and there's an x cubed. Both of them are going to get a power of 2 applied to it. So let's start with that. So we're going to get 2 to the power of 2. And then we're also going to get this x cubed to the power of 2. But remember, this is power of a power. These multiply, and this gives me x to the power of 3 times 2, 6. Okay, for now, we're just going to bring down this x to the power of 4. Okay, we're not done though, right? We can now go and notice, oh, we have 2 of the same base. We can actually multiply these together and use the rule where we add the exponents. Okay, and also I'm going to square this number just because we can. 2 squared gives me a 4. X to the power of 6 times x to the power of 4. Again, remember, we add the exponents. That's going to give us x to the power of 10. Okay, I just want to point out, it'd be very tempting to multiply these and maybe get a 24 in this spot. No, remember, when those base numbers are being multiplied, you add exponents. That's the very first rule. So here's the most simplified form of our answer. All right, so yeah, we're going to get into more exponent rules. There's quite a few of them, so we're kind of breaking it down, making sure we really understand these rules as they, kind of compound on one another. All right, guys, so yeah, I'll see you in class. Bye.